In this chapter, we're going to discuss some valuation issues, but in this case, we're going to change our focus away from securities, and now we're going to look at corporate projects. So this is an application of valuation to the decisions that are made inside the company for either replacement of assets or expansion of operations. So obviously the picture here, the thing that we're interested in, as we've discussed in other videos, is trying to find ways to maximize the value of a project or maximize the value of the corporation as a whole. So we're going to have to talk about how do we estimate cash flows. We'll discuss that in later videos. We're going to concentrate on a primary technique called net present value to help us to measure the value provided by a project. And of course, we're also going to talk about how we might have to adjust the cost of capital. Again, we talked about this in previous chapters, how we might have to adjust that based on the riskiness of the project itself. So what is capital budgeting all about? Quite frankly, it's long-term decisions. We're talking about large expenditures. It's really an implementation of the strategic plan of the company for the future. As I mentioned, there are several steps that are involved. We have to estimate cash flows. We have to assess the riskiness of those cash flows, determine what the weighted average cost of capital for the project is, and then in the end, obviously, we have to do an evaluation. We have to evaluate the information that we've gathered in the process. So what kind of categories are there, right? There's many reasons or many opportunities for purchasing assets in the company. And we can kind of categorize these into some basic areas. We can replace assets. We can expand our assets. We can contract or reduce the assets that we have. And then there are other things, safety or environmental projects. This is an entirely different strategy or process, right? Typically, safety and environment projects do not add value to the company. So where typically we talk about we want to find ways to maximize value, in this case, we're going to do that, but with the context is going to be in minimizing the costs. And of course, we also have merger activities. And we won't get to talk about merger activities in these videos, but obviously increasing asset size by buying other companies is just a variation of the expansion idea. Couple of things of terminology. We need to understand that there's a difference between independent and mutually exclusive projects. Why is this important? The whole idea with mutually exclusive projects is that we need to rank them and choose the best of a batch, right? So mutually exclusive, by definition, is if you accept one project, the other projects are eliminated. So when you're going out to buy a car, for instance, even as a consumer, you're not going to look at just one car. You may look at 3 or 4 cars. Then of those 3 or 4, you need to figure out the best of those 4. Well, if you only need one car, the other 3 are eliminated. So every project kind of starts this way as a set of mutually exclusive, and we need to determine the best. which technique do we do to determine the best? Again, we'll talk about this as we go through the techniques. Once we have eliminated all those that are unacceptable, we then have a set of independent projects, and that is our final set, if you will, or our opportunity set of projects that we might want to do. So we're going to look at a couple of projects here. And as you can see, we have two projects. They both have the same discount rates. We'll talk about reinvestment rate later. In later videos, we'll talk about how we determine cash flows. But for this, let's just assume that we've gone through that process and we have forecasted the cash flows moving forward. And this worksheet will help us to calculate all of these ratios, right? Or all of these techniques for the projects themselves. So let's start off. The first thing we want to talk about is the net present value. Quite simply, it's the present value of the inflows minus the costs. So the inflows are the cash flows that we expect to get in the future. And of course, the cost is the initial investment. So really, this is a cost-benefit analysis. It is a direct measurement of the change in the value of the firm and or shareholder wealth. So if the net present value is greater than zero, our assumption is that that project will give us a net gain in wealth. So you would accept all projects with net present values greater than zero. When you're choosing between mutually exclusive projects, you would choose that project with the highest net present value as it adds the most value to the firm. The internal rate of return. So if we look at our projects, taking a step back to our example of projects, if we look, this project, project A here we'll call it, has a net present value of $10,900 and B, $9,900. So if you're looking at these two projects, both projects are acceptable. If they were both independent, you would do them both. They both add value to the company. However, if you need to choose between the two, technically, project A is better because it is going to increase the value of the firm, increase the wealth of shareholders more. Now, if we go to internal rate of return, this is the definition they have in the textbook, I think, is confusing, but it's the discount rate that forces the present value of the inflows to be equal to the cost. So this forces, it's the interest rate that would give us a net present value of zero. So the internal rate of return, I think a better way to say this is it's an estimate of the project's rate of return. So it's comparable to the yield to maturity on a bond. So if we look at these two projects, the internal rate of return of A is 21.6, 17.7 for B. So again, should we do these projects? Well, let's look at the discount rate. The discount rate is the rate of return that you require as a minimum. And of course, both of these numbers exceed 10%, so they are both acceptable. Again, if they were independent, we'd do them both. But if they were mutually exclusive, you would choose the highest internal rate of return. So what is this overall rationale then? Well, again, if you think about the internal rate of return, if it's greater than the required return, by the way, this is the weighted average cost of capital, then this project's rate of return is greater than its cost. So it's an acceptable project. So if the required return's 10, internal rate of return's 15, we would say that this project is going to add extra return to the shareholders. So I've already mentioned that this is similar in the concept of yield to maturity, right? It's that rate that says, look, if the cash flows we forecast actually occur, this is the rate of return on the investment. Now, one of the things that we can look at is something called a net present value profile. Essentially, what this does is it takes the cash flows and it calculates the net present value at a stream of different weighted average cost of capitals or required returns. So for project A, at 3% required return or cost of capital, you would have a $21,777 net present value. At 21%, you would get a negative $3,400. So what we find here is what? As interest rates go up, as required returns increase, the values of the assets decline. And you can do that. What it does this for both, in this case, both projects that we have that we're analyzing here. So if we kind of look at this graphically, what we can see if we look at this graphically, what we can see is what? That as the discount rate increases, we find that the net present value declines. Where these lines, where these net present values cross the zero axis, this is the interest rate, this is the return or the cost of capital that would have a zero net present value. So in this case, we have internal rate of return is 18%. For the other project, the internal rate of return is 23%. So lots of things we can get from this. We can look at a crossover point. There is a point where one project changes our analysis of the project. If you look, we want to choose the highest net present value. L is better than S. But once we get beyond the crossover point, S is now better than L. So how do we look at this, or how do we analyze this? Well, let's think about our two projects, our two techniques. Let's start with the internal rate of return. Let's say we have a 5% discount rate. The internal rate of return of L is 18. That's greater than 5. And the internal rate of return of S is 23. That's greater than 5. So both of these projects are good with respect to this 5% discount rate. Now, if we go up above, we also then find that that L has a higher net present value. So at this point, what would we say? We would say that L is the better of the two projects using net present value, but S is the better project according to internal rate of return. So what if we move to a 15% discount rate? At 15%, again, we see that S still says that it is the better of the two projects according to internal rate of return. However, now S also has a higher net present value. So there is some conflict between our techniques, and we need to kind of understand how these things change. And we might want to, especially if we're choosing between mutually exclusive projects, we need to understand where this crossover point is relative to our required return. What's the likelihood, if we're at 5% discount rate, what's the likelihood that our discount rate would go over 8? Because that would then change the values of our assets and which asset is the better asset as far as value. So it's kind of a complicated problem, but it's very easy to calculate and see exactly what the relationships are. To find this crossover rate, we can do this with, we have a worksheet that will help us do this. Again, the crossover rate for our two problems here basically is 7.07%. So what this worksheet tells us, though, it says, look, 9,000 is the net present value, 10,000. Here are our numbers for our projects. If you calculate what we refer to as the incremental cash value, which of these two projects is better, we can then look at, calculate incremental cash flow. So you take project A's cash flow minus project B. Negative 60,000 minus a negative 45 is 15,000. Now let's find the information here. The net present value is a negative $1,000. So should we do project A? And the answer, since this is negative, it means this one has less value. And then it calculates the crossover rate. And the crossover rate is roughly 7%. So less than 7%, it appears that A will have a higher net present value, but to the right of 7%, B is going to have the better value. And we're obviously at a discount rate of 10%. So it turns out that a B is the better of the two projects. So why do these things cross? Two basic reasons. Number one, and I think these make some sense, right? The size of the company is going to make a difference. The internal rate of return is not influenced by scale, right? So if you double the size of all the cash flows, you would not have a difference in the internal rate of return. However, if you double the size of the cash flows, you're going to have a difference in net present value. Timing difference also is important, right? When do the biggest cash flows occur? So projects with faster cash flows provides more cash flows in early years. And if the the cost of capital is pretty high, that means these cash flows are going to be especially good. And those the net present value of those shorter projects in the front are going to be better than those in the long run. So again, kind of a long video here. Sorry about that, but I wanted to get to the end of this net present value concept. Look forward to seeing you in the next video.